Okay, good evening, everybody. Those who are live with us on the class and those who will be watching us on YouTube. It's March 20th, 2024. This is meeting number 12 in our overall curriculum. It is a virtual meeting number 6 in our virtual series of virtual meetings about specific industry topics in architecture, construction, engineering. This is actually the last of our subject matter meetings. It's virtual meetings. It's about the construction management industry. The only other virtual meeting that we have left will be specifically about preparation of your presentations. So this is the last actual meeting where we'll talk to you and give you some background information about the industry and how it applies also to your project. So myself, Jacob Katz at Pirtle Construction, and Matt Thompson of Stiles Construction, we're going to do the information in this presentation. Matt is going to start first with scheduling, and then I'm going to talk to you a little bit about cost information for your project and also how to manage site logistics during the construction of your project. With that said, I'm going to turn it over to Matt and we'll go into scheduling.
Okay, thank you, Jacob. Let me know if you could see my screen.
Yes, we do.
Sharing the wrong screen.
We see the right screen, Matt, I think.
Oh, you do?
Yep, we see the presentation.
Okay, just making sure. Okay, welcome. Good afternoon, everyone. I hope everybody's doing well, and thank you for joining this Zoom meeting before your spring break. And we know you guys are ready for spring break. So what I'm here to talk to you guys is about construction scheduling. My name is Matt Thompson. I am the Director of Scheduling at Stiles Construction. And just a little bit about me. A little bit about me. Yeah, I'm the Director of Scheduling at Stiles Construction. I'm a University of Florida BCN class of 2000 graduate. And yeah, that makes me old. 20 plus years of construction experience. So right now I'm pushing around 24 years in the field. And also I'm a graduate from Broward County Schools and Western High School class of 96, go Wildcats. So scheduling. There's two thoughts of scheduling. There's the red pill and a blue pill. So red pill, just to think about it, red pill, that mindset keeps thinking that the project is going just fine, dealing with problems as they come up, just reacting, being very reactive in that, so to speak. But the blue pill is always looking to prevent and solve future problems. You always look forward to see, preventative maintenance, preventative problems, preventative issues that you might have, even in life, in your house, even in school. You're trying to look forward to see what can cause a problem or what's a hard subject for you to get over or to comprehend. You start planning ahead, trying to say, okay, I need more time to study for this. And that's what a blue pill kind of mindset is. The red pill, you're just reacting, you're just cramming right before the test, trying to make sure you pass it, at least pass. But you want to excel in school. So you got to have a blue pill mindset. Start studying way before that. So proactive and reactive. For those that don't understand what proactive and reactive, this is going to be an explanation for that. And this is how scheduling is applied. Say you're responsible for planning a surprise party for your best friend. You figure out you have a lot of time. Since the party is a couple months away, you wait until the last minute to buy supplies and coordinate with everybody. The supplies you need at that time are sold out when you start planning. You blame the stores for not having what you need because you started doing it later on and close to the date. What's the result? Your friend has no surprise party. But being proactive You're responsible for planning that same surprise party for your friend. You begin planning months in advance. You start getting, getting a location picked out. You start thinking about the food, you start thinking about decorations, and anything that could go wrong, you try to prevent any issues or any problems. And guess what? Your friend has a great surprise party, and they are very surprised. So, what is a schedule? A schedule is a list of activities required to complete a specific task or goal. And within a schedule, there's activities, and each activity is assigned a specific duration. And as an example, there's things that you're going to do. Certain steps are going to take a certain amount of time. You get dressed, you brush, you make a peanut butter and jelly sandwich. There's a sequence of operations that you're going to do to make that peanut butter and jelly sandwich. Are you going to get the bread out, or are you going to get the peanut butter and jelly out of the fridge? It's up to you. But when you're putting together that sandwich, there's a sequence that you have to go. You have to get the bread first, right? Then you either get the jelly or the peanut butter, and you put it on one side of the bread. Then you get the other piece of bread. Then you put the peanut butter, the other opposite. If you did peanut butter first, then you're going to be putting jelly on the other side, and then you put them together. So those are the activities that you have to do in order to complete making your peanut butter and jelly sandwich. And then all activities are logically connected to each other, creating a sequence to achieve a specific goal. And like I mentioned, creating that peanut butter and jelly sandwich so you can eat is the goal. So in scheduling, there are softwares available to build a schedule. And what we use for construction, there are certain recipes that we have to come together and generate and create to build a building or create a project from start to finish. And these softwares allow us to put start and finish dates for each activity that's required for us to for these projects. So the scheduling softwares that are available, P6 Oracle, it's the Cadillac. It's the Cadillac of all scheduling softwares. It's like the Oracle, as some might say, no pun intended, like the Matrix. Excel is pretty powerful as well. It can do a lot of things, a lot of functions. Also, Microsoft created a software called Microsoft Project. Almost 15, 20 years ago, they created a software, Microsoft Project, so that's readily available. Ask the Power Project, that's a new software that's created that can do the same functions as Project and Excel, and maybe some of the functions that P6 can do as well. And also there's a new software out called Phoenix Project Manager. That's one thing that's out there that's brand new. So there's a lot of software companies coming out with scheduling softwares now and then. So we all have to test it and see and vet it out. So scheduling basics. So an activity is the basic component of a schedule. An activity represents a specific scope of work with a unique activity name. Each activity is assigned a duration, indicating how long the activity will take to complete. A milestone within that schedule represents a start or a finish point in a schedule. Milestones have a 0 duration. It's just saying this is the date you're done, or this is the date we're starting. A duration is the length of time assigned to each activity based upon a specific calendar. And we'll get to calendars in a minute. But let's look at activity. An activity has a start and a finish and a duration. A milestone has no duration, but it can represent a start or a finish within the schedule. So now we're going to talk about calendars. How many people like working how many of you guys like school if being 5 days a week? I don't see anybody. Does anybody like having school 5 days a week? Well, the school calendar is based on 5 days a week, but let's say, and that's how we schedule work in the field. It's a 5 days a week. Sometimes we go into Saturdays, or sometimes we work 7 days a week, depending on the project and depending on the owner. So that's why we create another calendar for 7 days worth work week, a 7-day work week. And that can capture a calendar time period like 365 days. And that's captured in that calendar of 7-day work week. Are there any questions? Oh, got a message. You think it's fine, Jaden? Okay. 5-day work week. Okay. So let's keep moving. So on to scheduling basics. When all the activities and milestones are put together and they're connected and sequenced, when properly created, the outcome is called a critical path method schedule, which is a CPM schedule. A CPM schedule defines the longest path from start to finish to complete a specific goal, which is usually a project. So a lot of references in construction is talking about the critical path method, or they'll say CPM most of the time, because CPM is that acronym that a lot of people pull towards, especially for like government projects and any project in specific, especially in the private sector. So to create that CPM schedule, there's activity relationships. The logical and activity relationships are the logical connection between activities. A predecessor is an activity that's before another activity, and a successor is the activity that's after another activity. And a loop, activity relationships that create a circular logic. And I'll show you a sample on that. And also an open end is an activity without a predecessor or successor. So here's the basics of an activity relationship, a finish to start relationship. Activity A has a finish to start relationship to activity B. So when activity A finishes, then activity B will start. And that's called a finish to start. Finish to finish relationship is when activity A finishes, activity B finishes at the same time. And that's called a finish to finish relationship. Another relationship is a start to start relationship. That start to start relationship means that, okay, when activity A starts, activity B starts at the same time. But an activity B is dependent on activity A. So when A starts, B starts. Now a loop, which is quote unquote frowned upon, and most softwares will not allow you to create a loop. It's when you start going back from activity A, activity B to activity C, and looping back and tying activity C to the start of activity A. And that's very incorrect. So you cannot have that. It's just going to cause errors within any software. If a software allows you to put a loop in, then that software is not good. Then open ends show that, okay, the activity E does not have a successor. So activity E needs something to tie to in order to create to help complete the logic in a CPM schedule. And just for all schedule purposes, there are only two activities with open ends. Is the first activity and the last activity. Whether it's a milestone or an milestone will not have a predecessor that starts it off, and a finish activity will never have anything after that, because you're finished, you're done. Now, total float. Total float are the days available before an activity pushes the completion date of the entire schedule. And the critical path is the activities that make up the longest path to complete a schedule. Now we're looking at this sample right here. We have activity A, activity B, and activity C, and it's all tied to this schedule completion milestone. Can anybody tell me in the chat which sequence is the longest path? Is it A and B, or is it activity C? Mentors are not allowed to chime in. Okay. All right. Jaden says A and B, and Jaden is correct. I will let Mr. Cantor know you answered. a question. So activities A and B have 0 days of total float, making that the critical path in the schedule and the longest path. Activity C has 2 days of float, because if you add the two activities A and activity B, that's a total of 8 days. But activity C has 6 days. So activity has 2 days less than activities A and B combined to get to the schedule completion. Therefore, activity C has only 2 days of total float. And yes, the critical path is going through activities A and then activity B to schedule completion. On a project, schedules are always changing. Actual dates are recorded and future dates are forecasted. As more information is available and changes to the specific goals are modified, the schedule will continue to evolve. So schedules are used to plan and manage work in the field. And that's what we do here at on any construction company, and that's what we do here at Stocks. We make sure that we have everything captured in the schedule and what we're trying to accomplish in the schedule. Sometimes it will push something out, a certain milestone out, and then we look at it and review it to see what's going to pull it back in. And that's how it evolves. Or we might say, you know what, we cannot start on this side of the building like we intended. We might have to change our sequence and come back a different way. Instead of starting from the left, we might have to start from the right, or we might have to skip a section and come back to it later. So scheduling basics. So the brown bars are the baseline schedule. And baseline schedules are the initial schedule that is generated at the beginning of the project. Or a baseline is capturing the time frame of when an owner makes a change, or there's a change in the project. Whether the owner says, I want to add on 5 floors, 2 floors to this area. And we say, okay, it's going to take a little bit longer. Okay, then the owner approves that extended time, and we capture that where we are, present time, when that change was accepted. And that's going to establish a new baseline to measure ourselves against. So right now we have the baseline bars, activity A, B, C, D, and E. And then as we status the project and we move the data date forward, which is this line here, which represents that date and time, we see that, okay, activity B started a little sooner than our baseline, and activity C went a little bit further, went 2 days past that. And then it created the critical path, and it pushed out the end date. Instead of us finishing on July 18th right here, we're starting to finish on July 22nd. That's what we're projecting. And I emphasize on the word projecting. Most of the work that we do, we try to project of when we're going to be done and try to accurately project it. 9 times out of 10, we're pretty accurate. There's that 1% or 10% chance that, something's not going to hit. And what we've been experiencing in the industry has been supply chain issues since COVID. So sometimes our baselines get changed and it shifts. And it causes us to not hit our target dates. One big thing is electrical items and electrical components. Those things have been dragging out and causing issues. As an example, we used to be able to get switch gear or any major electrical components within a 16-week time period or 20-week time period. Now we're hearing from vendors and from suppliers, it's going to be more like 40 weeks to 50 weeks. That's a big impact. Owners don't like that. They want to get their building open now. So that's when we re-baseline the schedule, say, okay, these are the expectations of when we're going to be done, and that's how we move forward on these projects with schedules. And then we can measure ourselves against that. So right here, I have an example of a building that we did here at Styles. This is going to be a time lapse of a building that we did down in downtown. Some of you might have been around might have been around and know what it is. It's we properly scheduled this project from demo to completion. And I'm gonna play this slide so you guys can see it. So what you're seeing is that in time, in accelerate in time-lapse photography, you're seeing the building come up. And all this comes together from creating the schedule, and then we're able to project and predict when we should be able to be completed. And we successfully completed these projects on time, despite COVID. And that's the gist of it, of just projecting out and just saying, okay, this is what's happened, this is how we project it to be, and forecast it out that all the stakeholders that are on those projects can expect when their asset is going to be done. Are there any questions yet? Okay. So when you think about scheduling, scheduling is proactive. Scheduling wins projects. Because why? Time is money. The longer you're on a project, the more money you're spending, the more money the owner spends. You want to try to get the job done as fast as possible, but the right way. Don't shortchange yourself in time. At least make sure you cover yourself. All right. Do we have any questions regarding schedule? Okay. Jacob?
Straightforward, huh?
Yes.
What about just before we move on, do you want to show um like scheduling, like templates, like little simple Excel schedule templates that we're gonna share with the students that they can probably use in their projects? I know
Sure.
I've got one or two that I think you and I have shared over the years, and um, um,
Yeah. Let me pull that one up.
and then I'll jump into my stuff real quick.
Say A, B. A schedule. There we go. Let me share this back up again. So let me know if you guys can see my screen.
Not yet, no. Oh, there it's coming now. Ah, there we go.
Okay. This is a simple schedule. We have the first month, second month, third month, fourth, fifth, sixth, and so on up to about a year, 12 months. We have the beginning of the month, the middle of the month, and the end of the month. You can highlight a cell, any color you like. You don't like green, if you're, if you want to be a gator and just be blue, start making stuff orange too, have at it. It's your project. But your schedule is going to have also a start point, which is a milestone here, like I described before, and a completion point right here. So you're going to have your mobilization, you clearing your site, prepping your site. Those are on waterfront developments. I'm sure there's some prep work that you're going to have to do. Get with your mentors and look at it and talk about it once you select your site. Underground work, foundations, walls and roof structures. You have your interiors, and you have your exterior work. Your interiors is your drywall, your painting, your light fixtures inside the building, your cabinets, anything that you're going to see inside of your building. Your exterior work is considered more about the exterior envelope of the building, which is your plaster, your decorative railings that's going on the outside of your structure or your development. sidewalks, your canopies, awnings, so forth and so on. The site work portion, that's going to represent mostly everything you have to do to complete it. Every time you walk out of your school, you're walking on a sidewalk, you're walking on asphalt. How are you going to get to your proposed development or project? That's what's done by site work, and that's the final stages of it. And then, of course, what most people miss is that there are final inspections at the end of a project. The city or the municipality has to come and inspect the project in order to close out a permit. Closing out a permit is very important because you do not want it to stay open. And just to make sure the city and or county or jurisdiction municipality make sure that you put everything in as per code and as per what's drawn. So a final inspections, actually being able to capture that time and say, okay, this is how long we have for final inspections is very important. And then that goes down into project completion. Once you have your final inspection, you are complete with your project. As far as with the city, you might have other things to do, and there's things called punch list that can take a little while to complete because they're more of like, okay, there's little errors and little defects that might be in the work that you had no control over, but you have to fix it. And the owner wants you to fix it. So,
And just while you leave that on here, Matt, I just want to jump in just to share with everybody. So obviously Matt gave a really good background and presentation on scheduling, and talked about some of the more complex tools and software that are used for scheduling. What Matt's showing you here is, a very simple Microsoft Excel. Another way of doing a very simple schedule is what I meant to say on Microsoft Excel, which is summarized to just a few lines that are the most common, I would say, Matt, most common way of summarizing a schedule, like with some of those
yes.
activities that Matt is showing. And I agree with that, being in the same line of work as Matt. So for your projects, and I'm talking to the students here, whether you chose the Olympic iconic structure, the shoreline design, we're looking for something like this, something on the more simplified approach. You'll be able to easily put this together, whether it's Excel or Google Office products or other documents that you use. We can even provide a blank template of this. We ask that you take some thought into the duration to build your project. We also ask you to do some research online, depending on what you're building for your project and what approximate durations are. You can see on the schedule, Matt is showing 12 months. Maybe some schedules though are a year and a half or maybe 2 years. If it's an Olympic iconic structure and it's a really large facility, might be a 2-year project. So those are the things that we ask you to think about for your project. And this is how a type of a schedule that we would like to see for your project.
And take in consideration what you're using for any of the specific elements that you have for your unique development or iconic structure. Google and see how long it's going to take to get certain materials for it. And just say, and if you might pop up, like I mentioned about switchgear and electrical components, major electrical components, and I'm sure Mr. Randall can chime in on that. It's real. There's a lot of things that has been affected in the supply chain. So it affects the schedule at the very end. And so take that in consideration and say, okay, you're looking for a special glass. And you could just Google, how long does it take glass windows or store curtain wall glass or a specific element that you like to incorporate in your project. Just Google that and say, okay, we can't finish it in 12 months. It's going to take us 14 or 16 months or whatever it might be. But just look at that, do some research on that as well and see for those key components. That's going to be very important.
Okay. Thank you, Matt. If you don't
You're
mind, I'm going to grab the screen.
Mhm.
So I'm going to use the last 20 minutes here, guys, and I will tell you that okay, my information is a lot more specific to what we want to see on your presentations or on your projects in general, relating to the construction management curriculum of the program. So I know Matt did a great job doing a background presentation. Instead of me doing a presentation, I'm just gonna get right into the specifics and the details of what we want to see in your project and give you some reference tools and resources that we'll also share with your teachers, who can then provide that information to each of you, the students. So let's start first with the cost and the estimating of your projects. And I want to start by explaining to you that the construction and design industry has standards that are used to organize not just the cost of a project, but also different design elements related to the project. And what you see here and what I've got highlighted in yellow, it's called the Construction Specifications Institute. The acronym is CSI for short, and that is the industry standard, CSI, for organizing construction cost and design and other information related to this industry. And what you see here on the left with all these sheets is basically a table of contents of this CSI standard. It's organized into 6 digits that goes all the way from 6 zeros. Let's see here, all the way to the very end to 487000. So, and as you saw, as I'm scrolling back up to the top, you see there's hundreds and hundreds of numbers in between. Now, I know it looks tedious and intense, but you know, not every one of, a lot of those numbers are very granular, and they're not commonly used in the everyday part of this business. So those of us who are in the design and construction industries are very familiar with the most commonly used 6-digit numbers. And that's how we organize, like I said, design specifications and also cost elements. So I'm just gonna share a few highlights as I scroll through this. And I'm not gonna spend a lot of time on this, but starting in division 02 and then 4 zeros is what's called existing conditions. I'm gonna jump to some more bigger common ones. Division 03 is everything related to concrete. So everything under 030000 is related to concrete and concrete related products, and then the cost associated with concrete. Division 04 is related to masonry. Division 05 is everything related to metals, so steel, aluminum, whether it's structural or decorative. And all those items are broken up and described in more detail under Division 05. Let's see, Division 07, that's thermal and moisture protection. So the items that are covered in Division 7 is stuff like roofing and caulking and waterproofing products. And as you can see, it goes into a lot of details about all the different types of products, different types of materials that fall under those trades. Let's see here, we got a few more. Division 8 openings, everything related to windows and doors on a project. Division 09 is finishes. What we mean by finishes is everything on the interior of the project or of the building that makes it look finished. So everything from drywall to paint to different types of flooring products, stuff like carpet, ceramic tile, vinyl floors, stuff like ceiling finishes, whether it's drywall ceiling, acoustical ceilings, metal ceilings. All of that type of information is covered under Division 09 for finishes. I'm going to scroll a little bit further down when we get into some of the more important infrastructure in buildings and where they're shown. So Division 21 is fire suppression. That's primarily fire sprinkler systems that you see in most buildings. When you get into Division 22, that's everything related to plumbing. And Division 23 is everything related to heating, ventilating, and air conditioning systems, commonly known as HVAC. And then last one I'm going to show you is everything in Division 26 is all about electrical. So this is, I'm just going to reiterate again, the industry standard CSI for organizing design information, design requirements and specifications, and also all the cost of a project is typically organized by division as well, which is what the industry is used to seeing. So now that I gave you that background, I'm going to show you this document, which once again will be provided to everybody. This is something that we created specific for the program, the ACE Mentor program. And what we're sharing with you here is a very common allocation of cost for a commercial building across the different primary CSI divisions. So for our projects this year, whether it's a shoreline design or the Olympic iconic building, those two projects or types of projects fall into commercial buildings. And we're showing you the common allocation of cost on a percentage basis through each one of these divisions. I'm just going to explain really quickly general requirements because you see here that it's equals to 15% of a project's cost. And what we mean by general requirements is that is all of your costs on the project, what we call soft costs, not necessarily the bricks and sticks of your project, which represent your actual construction materials. Your soft costs represents management and supervision, but staffing, management, and supervision. It represents insurance-related costs, overhead and profit for the contractor. Sometimes it includes contingencies and allowances. So those are the types of costs that fall into general requirements, also known as soft costs. It also includes your temporary expenses for managing construction. And what I mean by that is when you're building a project, you got to have temporary toilets for the construction workers. You got to have an office trailer for people managing and supervising the project to work out of. You also need to have temporary roads, temporary fencing, and gates to secure the property. Those are all the types of temporary costs that eventually get removed from the project. And the cost for that is captured in general requirements. And believe it or not, all those things add up to 15% of a project, approximately. So we're giving you the allocation, and we ask that every team potentially redistributes the allocation a little bit differently, depending on what your building looks like and what makes up your building. If you want your building to be built out of concrete, then your percentage of concrete and masonry may be a little bit higher, and your metals may be a little bit lower. If you want your building to be built out of steel, then maybe your metals will go up higher and your concrete and masonry will go lower. If you want your building to be covered with windows, which is not uncommon, then maybe your Division 8, which is openings, instead of 4%, might be closer to 10%. So we want you to look at all of these percentages. They all add up to 100%, obviously. So you need to make sure your cost eventually adds up to 100%. And this is how you allocate the percentage. And then we also want you to apply an actual cost to your building, because then you're going to allocate it based on these percentages and the dollars that you have for your building. So we will give you a number right now to use. And I will suggest that you use $500 per square foot for your project. And you can figure out what your project is worth by calculating the square footage size of your particular project and multiplying it obviously by 500. And that will give you your overall cost of your project. And then you can allocate that cost based on what you see on the screen here by percentage for every division after you make some changes to that percentage allocation. So again, let me reiterate, you can use $500 per square foot. Figure out the square footage of your building by doing some math and figuring out the size of your building. If you're doing a multi-story building, figure out what the footprint size is, and then multiply it by the number of stories of your building. And then that will give you, once you have your total square footage, you multiply that by $500 per square foot. That will give you your overall cost of your project. And then you can allocate it into all of these divisions here based on either the percentages that we're providing or based on some of the changes that you make to your percentages, like I suggested a couple of minutes ago. One other item I want to point out on this is with regards to, let's see here. With regards to the shoreline design, if you remember, one of the critical components of that is what are you incorporating into your project for protection of the shore from sea level rise and or erosion of the beach and the shoreline into the water. So depending on what you decide, oops, got the wrong box there. Your exterior improvements, which falls under Division 32, which are only shown as 2% here. If your project is heavily focused on that protection of the shoreline with the characteristics that you add into your project, that percentage will probably be much higher to capture the cost of that shoreline design, and then you'll have to reduce percentages somewhere else. So I'm just kind of giving you some ideas, a lot of things to think about. Obviously, this is being recorded, so you can watch this a couple of times if you need to refresh on everything I'm sharing and everything I'm saying. But this is what we want you to do for cost on your project, and how we want to see it from your project and with the information that we want to see. Okay. Last item I'm going to discuss is construction logistics, site logistics. So as I mentioned, when I explained general requirements, I said that a lot of the costs that it takes to manage, the temporary cost that it takes to manage a construction project over the life of the project, are captured in general requirements, and eventually those elements and costs are removed from the site when the project becomes finished and permanent. So we want you to put some thought into what it will take to manage the logistics of construction during the building process of your project. And we'd like you to do it graphically, similar to the examples I'm about to show. This is a school project that my company did in Orlando. And as you can probably see here, there's an existing classroom building, which is this structure in the middle. And our project was to build a new building on the right side of the property over here. So you can see we identified 2 rows of fencing that separated our construction area from the existing school, because the existing school stayed open while we were building. We are identifying it here with a note, double fencing. We're showing here the primary construction entrance into our project. We identified that the parent access will remain off of Wallace Road, so the parent access came through here in this little alleyway here and onto the main part of the campus. But we also use this as primary entrance. And we also had a office trailer located right in the corner of the property. And we had a secondary entrance over here. So these are just some of the examples that we, some of the ideas that we want you to think and to consider when looking at the property where you're building and how you're going to manage the logistics and construction. So this is one example. This is another school project. As you can see here, we showed what we call the laydown and staging area. This is where construction workers and companies stored material that was going to be used for the permanent construction. Once again, we had a construction office area. We also had a designated lunch area. These lines that you see in like red, brown color, those represent temporary roads that we built around the new building. This is the new building, by the way, in the middle here. So in order to access the new building with concrete trucks, with cranes, with pickup trucks, you have to have stabilized roads around the building. So that's what we represented over there. This is our main entrance over here. We identified fencing around the property. So just some different information that goes into planning and managing construction on a project that we want you to think about. We want you to do some research on online. We want you to look at these examples, and we want you to apply all of this to your particular project and your particular site that you've selected. Last one, I'm just going to show another quick one. This is actually using an aerial from Google Maps. And you can see here, this was also an existing school that was going to be torn down and rebuilt. We're showing a primary entrance. We're showing an area for laydown, staging, and construction offices. In orange here, we're showing how we're going to protect some important trees to this property. And obviously, we're showing the fencing around the project as well. Excuse me. So these are just some 3 examples that I'm sharing with you. We will also make all of these available to the teachers who can then share with each of the classrooms. We want you to work on, when it comes to construction management related to your project and the curriculum, we want to see a schedule, which is what Matt covered. We want to see the cost information based on what I explained. And we want you to think through site logistics during construction of the project, which are the examples I just showed. I wanted to wrap this up by 6 o'clock, so we're at 5:58. I'll open it up for any questions or any commentary from the other mentors on the call. Nobody? No thoughts from our other mentors? Any points of reference, Bruce? Yeah.
Yeah, I think it was a good presentation. I like the examples of the schedule, and these examples of the staging were pretty clear. So it gives the students a good level of understanding of like this information, and it could be easily applied. So it doesn't have to be anything very complicated. And you guys did show some good examples of how they could integrate it for their project. The pricing piece that you said too was also helpful, the $500 a square foot, so they could implement that. One of the funny things is seeing, sometimes the students' understanding of, how much is this gonna cost? Maybe 100 million. It's maybe gonna cost maybe something really low, but at least this is a good guide, $1 per square foot. So it was helpful. Thank you.
Just to share with everybody, probably 3 years ago, that number I would have recommended to use would be $350 a square foot.
Yeah.
The cost of, just like you probably hear, and I'm talking to the students, you've probably heard in the last 2 years, inflation.
Mhm.
Cost of a lot of things has gone up. The cost of construction and what it costs to build and design something has gone up significantly also. That's just the reality that we currently live in right now. Things are more expensive.
Thanks for the info.
Yeah, thank you, Bruce.
Yeah, I thought it was a pretty good presentation too, Jacob, and the cost per square foot information was great, and the scheduling piece was good too. But as a subcontractor, you probably don't want to hear my comments on on GC schedules.
Yes, we know. You're outnumbered though, Jeff, between me and Adam. Okay, well, thank you to our students who joined us live. Thank you to those who will be watching on YouTube. Have a great night, everybody, and we will see you in your classrooms. Bye, everybody.
Bye-bye.